A silent code may be whispering through every atom, every star, and every thought you have ever had. Welcome to Information World. What if quantum physics is not just a scientific theory, but the actual language of the universe? For centuries, humanity has searched for the fundamental structure of reality. We looked to the sky and built myths. We studied motion and discovered classical physics. We split the atom and uncovered nuclear forces. But when scientists began exploring the smallest scales of existence, something strange happened. The universe stopped behaving like a machine, and started behaving like a mystery. At the quantum level, particles are not solid objects. They are probability waves. They exist in multiple states at once. They seem to communicate across vast distances instantly. They appear to respond to observation itself. The deeper we look, the less reality looks like matter, and the more it looks like information. This raises a powerful question. What if quantum physics is not just describing the universe, but decoding its grammar? Think about language for a moment. Every language has symbols. Those symbols follow rules. The rules create structure. Structure creates meaning. And meaning creates reality in our minds. In a similar way, quantum physics describes fundamental symbols of existence: particles, fields, wave functions governed by mathematical rules that shape everything from atoms to galaxies. At the foundation of quantum theory lies the wave function. This mathematical expression does not describe where a particle is. It describes the probability of where it could be. Reality, at its deepest level, is not fixed. It is a cloud of possibilities. Only when a measurement occurs does the wave function collapse into a specific outcome. Before observation, a particle can exist in multiple states simultaneously. This is known as superposition. A famous thought experiment, Schrödinger's cat, illustrates this idea. Until observed, the cat is both alive and dead in a quantum superposition. This is not science fiction. Superposition has been experimentally confirmed in countless laboratory experiments. Electrons, photons, even entire molecules can exist in multiple states at once. If quantum states are like letters, superposition may be like a word containing multiple meanings at the same time until it is read. Then there is entanglement. When two particles become entangled, their properties become linked. If you measure one particle, the other instantly reflects a corresponding change, even if they are separated by light years. Albert Einstein famously called this spooky action at a distance. Yet experiments have confirmed entanglement beyond doubt. Reality appears to allow instantaneous correlations that defy classical ideas of space and time. If superposition is grammar, entanglement might be syntax linking distant parts of the cosmic sentence together in a way that transcends ordinary communication. This leads to a revolutionary perspective. Many physicists now believe that information is more fundamental than matter or energy. John Archibald Wheeler proposed the idea of it from bit. According to this concept, every particle, every field, every force emerges from binary yes or no answers, fundamental bits of information. In other words, the universe may not be made of things. It may be made of information. Quantum mechanics supports this view. The state of a quantum system can be described as information encoded in a wave function. When measured, that information becomes reality. Without information, there is no defined state. Even black holes have reinforced this idea. In the 1970s, Stephen Hawking discovered that black holes radiate energy and can eventually evaporate. This raised a disturbing paradox. If a black hole disappears, what happens to the information about everything it consumed? According to quantum mechanics, information cannot be destroyed. The laws of physics preserve it. After decades of debate, physicists concluded that information must somehow escape or be encoded at the boundary of the black hole. This led to the holographic principle. The idea suggests that all the information contained within a volume of space can be described on its boundary surface, like a hologram. Our three-dimensional reality may be a projection of two-dimensional information encoded at the edges of the universe. If this is true, the universe is not just matter arranged in space. It is information written across cosmic boundaries. Language has layers. Letters form words. Words form sentences. Sentences form stories. In the same way, quarks form protons and neutrons. Protons and neutrons form atoms. Atoms form molecules. Molecules form cells. Cells form organisms. Organisms form civilizations. Every layer follows deeper quantum rules. Even chemistry, the science of reactions and bonding, is governed by quantum wave functions. The shapes of molecules arise from the probability distributions of electrons. The stability of matter depends on quantum exclusion principles. The colors we see emerge from quantized energy transitions in atoms. Without quantum mechanics, there would be no stable atoms. No chemistry. No biology. No life. The language of the universe is written in probability amplitudes. Mathematics appears to be the alphabet of this language. The equations of quantum field theory, though complex, predict experimental results with extraordinary precision. The magnetic moment of the electron has been calculated and measured to match up to more than 10 decimal places. This level of accuracy is unmatched in science. It is as if the universe runs on code and mathematics is the syntax that reveals it. Quantum field theory goes even deeper. According to this framework, particles are not tiny solid beads. They are excitations of underlying fields that fill all of space. The electron field exists everywhere. When it vibrates in a certain way, we observe an electron. Reality becomes less like objects and more like vibrations in invisible informational fields. This idea echoes ancient philosophical concepts that described the universe as vibration or resonance. Yet now, modern physics provides mathematical support for such visions. Some researchers even propose that space-time itself may emerge from quantum entanglement. Instead of space being a fixed stage where events happen, it may be a network woven from quantum information connections. In this view, geometry arises from relationships between entangled states. Space is not fundamental. Information is. Time, too, may not be fundamental. At the quantum level, many equations work equally well forward and backward. The arrow of time appears linked to entropy, the growth of disorder. But entropy itself can be interpreted as missing information. The flow of time might be the universe processing information. Quantum computing further reveals the informational nature of reality. Unlike classical bits, which are either 0 or 1, quantum bits qubits can exist in superpositions of both. They harness entanglement to perform calculations that would be impossible for classical machines. If quantum mechanics is the universe's language, quantum computers may be humanity's first attempt to speak it fluently. But perhaps the most mysterious aspect of quantum physics is the role of the observer. In many interpretations, measurement plays a crucial role in defining outcomes. Does consciousness collapse the wave function? Or does interaction with the environment cause decoherence? Scientists continue debating this deeply. Some interpretations, like the many worlds theory, suggest that all possible outcomes actually occur in branching universes. Instead of collapse, reality continuously splits into parallel histories. If so, the quantum language is infinitely expressive, writing countless cosmic narratives at once. Other interpretations emphasize relational properties. A particle state is only defined relative to another system. Reality becomes a web of interactions rather than independent objects. Language requires context. Meaning arises from relationships between symbols. Perhaps the universe works the same way. Information theory connects beautifully with thermodynamics. Claude Shannon defined information as a measure of uncertainty. The more uncertain a system, the more information is needed to describe it. In quantum mechanics, uncertainty is fundamental. Heisenberg's uncertainty principle states that certain pairs of properties like position and momentum cannot both be precisely known. This is not a limitation of technology. It is built into reality. The universe limits how much information can exist about a system at once. Even empty space is not truly empty. Quantum fluctuations constantly create and annihilate virtual particles. The vacuum is alive with informational activity. Fields vibrate even in their lowest energy state. Nothingness is not nothing. It is a sea of potential information. When we look at cosmology, the early universe appears to have begun in a highly ordered, low-entropy state. Tiny quantum fluctuations during cosmic inflation were stretched across space, seeding galaxies and large-scale structures. The cosmic microwave background radiation preserves patterns of those ancient quantum fluctuations. The largest structures in the universe were born from microscopic quantum noise. The entire visible cosmos may be a magnified echo of quantum information. If quantum physics is the language of the universe, then gravity remains its missing chapter. Physicists are still searching for a theory of quantum gravity that unites general relativity with quantum mechanics. String theory proposes that fundamental particles are tiny vibrating strings. Loop quantum gravity suggests that space itself is quantized into discrete loops. Both approaches attempt to describe the deeper grammar beneath space-time. We may be standing at the edge of a new translation. Some scientists believe that reality may resemble a computational process. Digital physics suggests that the universe evolves according to informational rules similar to a vast quantum computer. Seth Lloyd once proposed that the universe itself is performing quantum computation. If this is true, existence is not just happening. It is being calculated. Yet this idea raises profound philosophical questions. If reality is information, what is information made of? Information requires a physical medium to exist. Bits need hardware. What is the hardware of the cosmos? Perhaps quantum fields are that hardware. Or perhaps something even deeper underlies them. Consciousness adds another layer of mystery. Our brains process information through neurons and electrical signals. But at its core, perception may be shaped by quantum events within atoms and molecules. While mainstream neuroscience does not require quantum effects to explain consciousness, some researchers explore the possibility that quantum coherence could play a role in cognitive processes. If consciousness itself is a pattern of information, then we are not separate from the cosmic language. We are expressions of it. Every thought you have is a rearrangement of atomic configurations governed by quantum rules. Every emotion is encoded in molecular interactions shaped by probability amplitudes. You are quantum information, temporarily organized into self-awareness. This perspective changes how we see reality. Instead of a solid world made of rigid matter, we inhabit a dynamic informational network. Instead of isolated objects, we encounter interacting patterns. It also changes how we see knowledge. Science becomes translation. Each equation is an attempt to decode the syntax of existence. Each experiment is a conversation with the universe. The remarkable success of mathematics in describing physics has puzzled philosophers for centuries. Why should abstract symbols invented by human minds correspond so precisely to physical reality? If the universe is fundamentally mathematical, if its language is written in equations, then perhaps our minds resonate with its structure because we are made from the same informational foundation. The idea that reality is information does not diminish its wonder. It deepens it. Information can generate unimaginable complexity. From simple binary rules, digital systems produce vast virtual worlds. From simple quantum rules, the universe produces galaxies, life, and consciousness. The language may be simple. The story it tells is infinite. As research advances, new discoveries continue to reinforce the centrality of information. Quantum error correction codes appear in theories of space-time geometry. Entanglement entropy relates to gravitational dynamics. The boundaries between physics and information theory blur more each year. We may be witnessing a shift in worldview as profound as the Copernican revolution. Just as Earth was not the center of the cosmos, matter may not be the foundation of reality. Information may be. Yet mysteries remain. Why do quantum laws have the form they do? Why does the universe obey consistent mathematical structures? Why is there something rather than nothing? Perhaps the language has deeper layers we have not yet learned to read. Every time scientists build more powerful particle accelerators, more precise detectors, and more advanced quantum computers, they are not just exploring matter. They are listening more carefully to the universe's whisper. The quest continues. What if the stars shine because of informational rules written at the dawn of time? What if gravity curves space because of entangled quantum states beneath perception? What if your own awareness is the universe reflecting on its own code? If quantum physics is the language of the universe, then existence is not random noise. It is structured meaning emerging from probabilistic grammar. And we are both readers and participants in this cosmic text. The atoms in your body were forged in ancient stars. The quantum fields that sustain them stretch across the entire cosmos. The same equations that govern distant galaxies govern your heartbeat. You are not separate from the language. You are one of its sentences. And perhaps, as we continue decoding quantum reality, we will discover that the ultimate question is not just how the universe speaks, but why. Thank you for exploring this profound idea with us. If you enjoyed this journey into the hidden language of reality, make sure to like this video and subscribe to Information World for more deep explorations into science, mystery, and the universe itself.